In this video, we're going to talk about how to find vertical and horizontal asymptotes. Now, we say the line x equal a is a vertical asymptote of the graph of f when f of x gets large or f of x gets large in the positive or in the negative direction as x goes to a from either side. What does that look like? Well, so that would look like if this were x equal a, that would mean, so we section that off by putting a dotted line there. And that means x either goes down this way or up that way on one of the two sides, okay? So we might get something like that. You might have, and I mean, you could have something like this. You could have something like it goes up this way and then nothing happens on that side, or you could have it go down that way. I mean, and any sort of combination of these different things, right? So if this is A, you could have it going sort of down this way, okay? Anyways, you have lots of different possibilities here. You could have down. Anyways, lots of options. This is by no means exhausted. But the basic idea is that x, it's sort of like the graph is trying to get around this vertical line, but can't. And that's sort of what it means. The line y equal b is a horizontal asymptote of the graph of f when f of x approaches some value b as x gets large in the positive or negative directions. So this is all about end behavior. Namely, if this is some value b, the question we're sort of asking is, what happens as we go out this direction? Well, the graph might look like this, for instance, and get really, really close to there. And so as time goes on, as x gets large, it gets really, really close there. Of course, you could have a different horizontal asymptote, possibly, or it could have gone back up. But as time goes on in the negative direction, okay? So if it does either of those, then it's a horizontal asymptote. The good news in all of this is that there's a simple procedure to find them. For n, so if you have a rational function n of x over d of x, that is some polynomial over another polynomial, n being the numerator polynomial, d being the denominator polynomial, we also want them to have no common factors. We'll talk about that when we talk about graphing rational functions, of sort of what happens if there is a common factor. We say that the graph of f has vertical asymptotes at the zeros of the denominator. So wherever the denominator is 0, we expect to get vertical asymptotes. We saw that a little bit in the last video. Also, we can determine horizontal asymptote for f by the following criteria. Consider the degree of the top and the degree of the bottom. If the degree of the top is less than the degree of the bottom, namely the degree of the bottom is larger, then the line y equals 0 is going to be a horizontal asymptote for the graph. When they're equal to each other, the line y equal an over am, the leading terms, when the degrees are equal, the leading coefficient put in a fraction is going to be our horizontal asymptote. Finally, when the degree of the top is greater than the degree of the bottom, then f actually doesn't have a horizontal asymptote. However, something interesting does still happen, and we'll talk more on that in a later video. So, for example, let's go ahead and find all the vertical and horizontal asymptotes of the graph of each of the following rational functions, okay? So for the first one, the best thing to do here is factor the top and the bottom to see if anything cancels. Here we have 2 times x times x. On the bottom we have x minus 1 times x plus 1, because we know a difference of squares factors into conjugates. Here we see no common factors, which means the zeros of the denominator must be our vertical asymptotes. Namely, we see that the vertical asymptotes, which I use VA for, is x equal either 1 or negative 1. Now the horizontal asymptotes, we see that the degree of the top, the degree of the numerator, equals the degree of the denominator, which is the bottom. In other words, what we have here is that meant that if we take the leading coefficients, that should be our horizontal asymptote, namely y equal 2 over 1. That is y equals 2. So those would be the horizontal and vertical and horizontal asymptotes. Similarly over here, again, we should factor it. We say that we have this factors into x plus 2 and x plus 2 and x minus 1. The bottom factors into x plus 2 and x minus 3. And we see here that these actually cancel with each other. Well, that actually creates something called a hole. So that is a hole at x equal negative 2 when that's 0. Okay? Again, more on that in a bit. Basically, it means, yeah, the graph is going to, yeah, you're going to have a hole there. XO, what this means is our only vertical asymptote is when x is equal to 3, because that's not a common factor. Of course, our 0 would be 1. Horizontal asymptote would be, well, the degree of the top is equal to the degree of the bottom, so y should equal 1 over 1, which is 1. And now it's time to have you try an example, so go ahead and find all the vertical and horizontal asymptotes of the graph of 3x squared plus 7x minus 6 over x squared plus 4x plus 3. On the count of 3, I'll reveal the solution. 1, 2, 3. So here we see that because the factors cancel, we get a hole at x equal negative 3 in the graph. We also have a vertical asymptote at x equal negative 1 and a horizontal asymptote at y equal 3. If you'd like to actually see what this graph looks like, then, and that's what it would actually look like. Again, notice horizontal asymptote at 3. I plot some extra points to help out. Vertical asymptote at x equal negative 1, and we even have a hole at x equal negative 3. Again, we'll see more of this in our next video. For more on finding vertical and horizontal asymptotes, be sure to see the textbook page 175 and work problems 2, 3, and 9 through 16. In our next video, as I said, we'll talk about sketching rational functions.